In this section, we'll be talking about solving systems of equations. So the system of equations is two equations that have two variables in them. There are larger systems, but we're only going to worry about the ones that contain two variables and two equations. So using the substitution method, you can solve one of the equations for one of the variables, and it doesn't matter which equation or which variable. So you're going to pick the easiest one, and then substitute for that variable in the other equation, and then you'll solve for the remaining variable. However, if you can't do that, then for instance, if the variables go away, if the resulting equation is never true, there's no solution. If the resulting equation is always true, there's an infinite number of solutions. Let's see how that works in example 1. First thing we're going to do is look at these two equations, and we're going to look for an easy way to solve for one of the variables. Well, definitely that second equation looks like an easier one to solve for one of the variables because you only have to subtract in order to solve for one of the variables. It doesn't matter which one you solve for because both of them are very easy to solve for. Second thing I'm going to do is I'm going to write that second equation in another column. This just helps me keep track of my work. And then I'm going to take that first equation and replace the a in the second equation with 15 minus b. And then distribute. That'll give us 45 minus 3b minus 2b equals 5. So we have negative 5b and 45 equals 5. Subtracting 45, we'll have negative 40. So dividing by negative 5b is 8. And we'll take that b equal to 8 and go back to the first equation and replace the b with 8. And that's going to give us an a of 7. So it's an ordered pair 7, 8. That is an a, b. And let's just check the results. Using that first equation, 3 times a, so that'd be 3 times 7, is 21, minus 2 times b, which would be 2 times 8, is 16. So 21 minus 16 is 5. Check. Using the second equation, a plus b is equal to 15, 7 plus 8 is equal to 15, check. So it's important that you realize that you can check your solution so you know whether your answer is right. All right, let's take a look at the next one. We've got two equations, so I'm going to put one here in the first column to work with, and I'm going to put another one in the second column to work with. So the first step is to take either one of those two equations and solve it for one of the two variables. Well, guess what? This one's already solved for one of the variables. So let's just take it and replace the y in the second equation with 1/3 x minus 5. And then we have a single variable equation, so we can solve it. We're going to want to clear the fractions, so I'll multiply both sides of the equation by the least common denominator of 6. And doing that multiplication, 6 times 1/3 is 2, so I've got 2x minus 30 equals, and 6 times 1/6 is 1, so we've got 1x minus 3 times 6 is 18. Subtract off an x from both sides, and then add 30 to both sides, and we'll get x equals 12. Let's take that x equals 12 and substitute it back into the first equation. And so that's going to give me 4 minus 5 is negative 1. So it looks like we have a 12, negative 1. X always goes first in the ordered pair. You can check that. I'm going to skip that step. In C, we can solve this one by substitution. This second one is yelling out to me to be solved for x. Since x has a coefficient of 1, it's going to make it much easier to solve for a variable. So x is equal to 3y plus 4 if I solve it. Now I'm going to write the other equation at the top of the other column here and replace the x with 3y plus 4 in it. Remember to copy everything as you go from one line to the next. So now distribute 6y plus 8 plus 3y is equal to 14. So now I've got 9y plus 8 is equal to 14. Subtract off that 8, and we've got 6. So y is equal to 6/9 or 2/3 when we reduce that fraction. Do simplify all of your fractions. Take that and go back to the first equation here and replace the y with 2/3. So now we've got x is equal to 2 plus 4 is 6. So our ordered pair is the x, comma, the y value. Let's try D. That first equation looks like one that could be easily solved for y, since y has a coefficient of 1. So y is equal to 2 minus 3x. And let's see, let's write the other equation at the top of the second column. We're going to now substitute for y in the second equation, and we're going to replace the y with 2 minus 3x. Now, combining like terms on both sides of the equation, you'll notice that 6x and minus 6x add up to 0, so we now have 4 equals 4. That statement is always true, so that means that there is an infinite number of solutions to this equation, to this system of equations. It's not all real numbers are solutions. It's just numbers that fall on the line y equals 2 minus 3x. So distinguishing between infinite number of solutions and all real numbers. All right, why don't you try the next one on your very own? Pause the video. All right, hopefully you got the solution of 5, 3/4. All right, and let's try the next one below. I think that's our last try this problem. So now try B. And this one has a solution of 6, -2. That's it for this section, but we're going to move on and we're going to cover as well solving by the addition elimination method. Now, the method that you and I used in the first section here is a nice method to use if you already have a 1x or a 1y in one of the two equations. However, for the addition elimination method, we can leave those equations in standard form, and if the a and the b coefficients are not necessarily 1, it makes it much harder to do the substitution method. So what we're going to do is we're going to multiply those equations by coefficients, by a constant, so that the coefficients of one variable are opposites. We're thinking least common multiple there. And then when we add them together, those variables are going to disappear. All right, let's see how that works in practice. So in A, our coefficients of the y variable are already opposites. So if we just add them together, 2x plus 0y equals 5 plus 7 is equal to 12, then we can get x equal to 6, and then just substitute into one of the two equations. It doesn't matter which one. So x is 6, so 6 plus y is equal to 5. That's going to give us a y of -1. So our solution for this system is 6, -1. All right, let's take a look at B. In B, these coefficients of the x variable are almost opposites. We can create them to be opposites by multiplying the second equation by -1. So now I'm just going to rewrite our equations with that multiplication. You need to remember to distribute that to all terms in the equation. So -x minus 2y equals -4. Adding the two equations together now, x plus -x is 0. 4y plus -2y is +2y, and that's equal to 1 minus 4 is -3. So our y value is -3/2. Now substitute into either one of the first two equations. So x plus 4 times the y value is equal to 1. That's going to give us x minus 6 is equal to 1. And so x must be 7. So 7 is the x value and -3/2 is the y value. In C, our equations don't have opposite coefficients. The easiest one to get to cancel out would be the y's. They already have opposite sign coefficients, and all I have to do is multiply equation number 1 by 4, and then that's going to give us 16x plus 4y is equal to 20. And when we add that together with the second equation, the plus 4y and the negative 4y are going to cancel each other out. So if you notice that the least common multiple of these two coefficients that we're talking about here, the least common multiple of 1 and 4 is 4. So we need to make sure that the y coefficient is 4 by multiplying that equation by 4. That's going to give us, adding the two equations together, 19x plus 0 equals 19. So x must be 1. And now take either one of the two equations. So I'll just write 4x plus y was equal to 5 was one of the two equations. And you can replace x with 1. And that's going to give us y plus 4 is equal to 5, so y must be 1. So it looks like 1, 1 is the ordered pair solution. We have a similar setup in D. We have a 1x and a 3x. It would be real easy to just multiply that first equation by negative 3 to create a negative 3x coefficient in the first equation. So now let's distribute that to all terms. Negative 3x minus 9y equals negative 30. And then I'm just going to bring over that other equation so that we can line them up to add them together. X coefficient, or the x terms add up to 0. Negative 9y plus 4y is negative 5y. And negative 30 plus positive 10 is negative 20. That gives us y is equal to 4. And we have that x plus 3y is equal to 10. Although you can use the second equation, this seems like an easier one to use. And we'll replace the y value with 4. So we have x plus 12 is equal to 10, and x is negative 2. That gives us an ordered pair negative 2, comma 4. All right, let's get to the ones that are a little bit more advanced. In E, we have no 1 coefficients at all. So we can approach this by eliminating either the x terms, and their coefficients are 2 and 3, so I would want to use a least common multiple of 6, multiply equation number 1 by 3 and equation number 2 by negative 2, or I can choose to eliminate the y variables. And so since their equations are, since their coefficients are 5 and 2, then we'd want to use 10 there. I'm going to eliminate the y's because I feel like it's easier to multiply both equations by a positive number than a negative number, and their signs of those terms are already opposite. So 2 times the first equation gives us 4x plus 10y equals 2, and 5 times the second equation gives us 15x minus 10y, it's supposed to be a 10, is equal to 55. Adding them together, we get 19x equals 57, and dividing by 19, x is 3. And then we can take either one of the two equations, so I'll use 2x plus 5y is equal to 1, and if I replace the x with 3, that's going to give us 6 plus 5y is equal to 1. So 5y is equal to negative 5, and y is negative 1, so 3 comma negative 1. In F, we have, let's see, looks like we can make our x's cancel out fairly easily by multiplying this first equation by negative 3. That'll give us negative 3x minus 12y equals negative 30. And then bringing over the second equation, 3x plus 12y is equal to 20. Adding those two together, we get 0 plus 0 equals negative 10. Well, that equation doesn't have any variables in it, so we can't solve for the variables. And it's never true That must mean that there is no solution to that system. All right, your turn to try using the addition elimination method. Try A. The solution to this first system should be 7, negative 10. I chose to eliminate the y variable, but if you wanted to use the least common multiple of 12, you could have eliminated the x variable instead. Should give you the same result. All right, now your turn to try B. This system has an infinite number of solutions, since when you eliminate the variables, you get 0 plus 0 equals 0, which is always true. That's it for this section.